Again, my name is Daniel Moyer, sales support trainer here. Let's go ahead and get started. Let other people trickle in. Start really quickly with history. Not going to spend a lot of time here. We originally founded in 2010 as OES Energy. Back then, lithium ion batteries were just starting to hit the market. And a lot of people were coming to the market with cobalt-based batteries. They were having a history of going into thermal runaway, of being unsafe. We were one of the very first companies to come to market with a lithium iron phosphate battery. So a much safer chemistry. And we've been making them ever since then. We, like I said, originally founded as OES Energy, where we were in the film and broadcast industry. So mobile packs, if you can imagine. 2011, 2012, we had a great opportunity to partner with the military, the Department of Defense. At that time, they were using a lot of diesel generators at some of their forward operating bases, lead acid batteries that weren't performing. We approached them with a lithium ion battery. They said, no, we don't want lithium ion batteries. We heard cobalt's unsafe. Well, we said, we actually have a safer chemistry, lithium iron phosphate. So they tested it, took them out to Aberdeen Proving Ground out there on the East Coast, and really rigorous testing, high temperature, high movement testing. So they liked what they saw, we passed, and we ultimately did deploy with them. So it was a really big win for us. 2013, 2014, we began to expand our product line. This is when we introduced our PHI battery, which has still been one of our best-selling bread and butter batteries we've been selling. We also released some mobile power packs and really just started to expand our diverse solutions. 2015, 2016, we relaunched as SimpliPhi Power. We introduced this Access Energy Cabinet, a totally integrated ESS. We also continued to work with the military, which was really cool to have them prove out our batteries. 2017 to 2020, we've been ramping up manufacturing at our headquarters and our production facility down in Ventura County, which is in the city of Oxnard, California. So we actually do assemble these batteries down in Southern California. We also released our SimpliPhi battery, which I'm going to talk about a little bit later. That's just like the standard PHI battery, but it has some closed loop communication capable battery management system, a much more advanced battery. So when it comes to selling energy storage systems, most customers, they're looking for three things. One, they're looking to save money. Two, keep their lights on when the neighborhood power goes out. And three, help the environment. So to save money, an energy storage system can do a couple things. One, energy costs have just been going up across the board. I know where I'm at in Pacific Gas and Electric territories, it's gone up a lot more than 15% in the last 10 years. But what they're doing is some unique things. They're forcing a lot of people onto time of use rates, where during certain times of the day, 4 to 9, 5 to 10, electricity is much more expensive. Well, we can tell an energy storage system, look, go ahead and discharge yourself during these expensive times of the day, power the home's loads. And when power's cheap, go ahead and start buying from the grid again. Another way an energy storage system can help us save money is by offsetting surge pricing. So that's if any time during the day you exceed a certain kilowatt threshold of consumption, the battery knows that, and it will start discharging itself so it can flatten out those curves. I know, across the world with these energy prices just going up, saving money is definitely something that you can approach customer with and let them know. If you're on somebody with a diesel generator, everyone knows how much more expensive diesels become. We can reduce those diesel generator runtime hours. We can use a diesel generator, charge up a battery, shut the generator down, save fuel, save runtime on that engine. So saving money is definitely going to be a nice, attractive thing to a customer. I feel like the most important benefit and something that most people are really going to want to go storage is keep their power on. Give them the resilience, give them the distributed asset at their home that's going to keep them powered while the neighborhood's down. There's, of course, economic forces that are driving this. A lot of the grids around the country aren't being maintained the way they should. There's a lot of weather events like the ice storms in Texas or the fires here in California that are causing these public safety shutoffs for our power grid. You know, there's nothing safe about shutting down our power grid, essentially. So what is it worth it to a homeowner, to a business owner, to keep their power on? It's almost priceless. The last thing is really environment. And I'm not going to sell that one short. A lot of people do care, and I do care about moving our society to a clean energy goals. And by using storage, home storage, distributed assets, we're able to capture some of that renewable energy that is really an intermittent power source, right? Solar, wind, it's not being generated all the time. So if we can store that and capture that, we can then use it and help stabilize the grid. We're going to run through some of the chemistry and form factor on the battery before we jump into some of the other advantages. Like I mentioned before, safety was really one of our founding goals, and using lithium iron phosphate as our chemistry is really the most inherently safe of all of the lithium ion battery chemistries, especially when compared to cobalt-based chemistries. It's not just chemistry that makes our battery safe, it's also our form factor, the way we build things, the way we have our intellectual property with our battery management systems, the way we pack those cell packs are built. And one of them makes it is the form factor is a cylindrical form factor. So think AA, think AAA batteries inside of this battery module. And a cylindrical form factor is inherently safe because it has a metal case. So it's going to contain any event that should occur. It has the positive and negative terminals at opposite ends of the battery. And it gives us a lot of performance. Pouch cells, which are probably the cheapest of all of the form factors, essentially has nothing but tin aluminum foil between the cells. It can swell, it's prone to puncture and off-gassing. Prismatic cells, there's nothing wrong with those. They tend to be a little bit bulky. So we really found that cylindrical form factor is what gave us that advantage. When you're approaching a customer, warranties are always important. We want to keep it simple. We give a 10-year unlimited cycles, 100% depth of discharge warranty. You're going to see in some of our competitors, they might say much more complicated warranties. They might say a certain amount of megawatt hour throughputs, a certain depth discharge, a certain number of years. Really, we want to keep it simple. And at the end of our 10-year warranty, we have a retained capacity of the battery of 80%. And that's more than a lot of our other competitors. So that being said, you can discharge them to 100%. Really, if you're going to be cycling these daily, you're going to be using them in an off-grid situation or a time of use arbitrage, we want to see an 80% planned depth of discharge. It's going to give your customer the most life of the battery after that warranty period's done. If you're in simply a backup situation, or maybe a situation where you're really not cycling the batteries, go ahead and size for 100% depth of discharge. And I should mention, we have other trainings, both upcoming live trainings and pre-recorded trainings on our YouTube channel that go deeper into how to size these systems based on these depth of discharges. So check them out. Definitely people that are in cold climates are going to want to hear how their batteries are going to keep operating when it gets cold. Now, the operating temperature, which is discharging or in idle situations of our batteries, is -4 degrees Fahrenheit up to 140 degrees Fahrenheit. Charging temperatures, you never want to charge really any lithium ion battery but when it's below freezing. So if you are in one of those situations, we have solutions. And again, we have other trainings that go where the whole hour or half hour we spend talking just about cold weather environments. We talk about heating pads. We talk about insulated battery cabinets. We talk about ways to understand the temperature gradients between inside the battery and ambient temperatures. So there's a lot of solutions out there. Reach out to one of our sales application engineers, reach out to me. and I'll connect you up with someone. I'll go into this here in a second, but I don't want to get ahead of myself. There's no coolant, ventilation, or HVAC equipment required for our batteries. Those are all other modes of failures that could fail, that cause the battery to fail. And we'll talk about it here in a second. There are other competitor batteries that need those pieces of equipment to operate. Internal to all of our batteries is a battery management system. We really have three types. A simple internal only battery management system that's found in our standard Phi batteries. We have a much more advanced communications capable battery management system that's found in our SimpliPhi batteries. And then we have a third type of battery management system. It's called the stack controller in some of our high voltage equipment. Really, a battery management system's doing cell balancing. That's really the main reasons it's in there. But it can also offer some other protections: overcurrent protection, short circuit protection, charge and discharge protection. It's kind of the last line of defense. It's never an excuse for a poorly programmed or poorly sized system. But if it doesn't see things it likes, the battery management system's simply going to open itself up to protect it. If it gets too cold, the battery management system in the SimpliPhi batteries can tell pieces of equipment to slow down charging rates, and at some point even stop charging. So the more advanced battery management system is nice because it's going to be able to communicate pre-programmed set points into pieces of equipment, offer that cold weather protection, and really tell those pieces of equipment, tell those inverters, tell those charge controllers what its state of charge is. They also have a built-in breaker, which makes it really nice for installing the battery. You can turn the battery off essentially, so you're not worried about shorting out those battery terminals. It helps with troubleshooting as well. When you're talking about these batteries and why you should go with these batteries over other solutions, one key feature is the ability to charge and discharge the battery quickly. We want to discharge the battery quickly so we can provide that load, the support to those loads you might be seeing. But we also want to be able to charge the battery quickly. So if we have a short solar window where we only have solar for a certain amount of time during the day, well, we can charge that battery up quickly, top off the battery, and then have that extra solar in the afternoon to run what I like to call luxury loads. You know, start doing other things before the sun sets, before the evening comes around. Do your laundry, turn those lights on, maybe run a little heat pump. And by able to charge a battery quickly, you're going to get that, that ability to kind of have the luxury loads in the afternoon. Also use a generator at full capacity, not run it at an idle rate. Our batteries have a C/2 rate, which means that if you have a 3.8 kilowatt hour battery, you can charge or discharge that battery at 1.9 kilowatts. Another exciting thing that I always like to say when I come to a homeowner is like, let's get you started. They may not be able to afford the system that they want at that time. So we'll get you started. We can always expand the battery bank. That's not something that's very common in our industry, where you can come back to somebody, add batteries to an existing system. Of course, we don't want to go too long. Maybe 2 or 3 years is about as long as you're going to want to go before you add batteries to the system. And you want to be careful when you're coupling the new and old batteries. We want to see that they have a voltage no different than about 1 volt. So we're not seeing a lot of current flow between batteries. We can scale up the system to let the homeowner know we're not going to work in these small, these larger chunks of energy storage. We can scale up at 3.8 kilowatt hour increments, or even less or more, to scale up the system that make the both the energy capacity that they need, the autonomy that they need, and also scale up in the power to support those loads. So here's a couple examples of what it looks like to expand. Here we had 8 batteries connected up to this old SMA Sunny Island, it looks like, inside this combiner. We came back and added 8 more batteries, scaled up that system to make it the size that they needed to give them that autonomy. Here's something where we scaled up 80 of our PHI batteries. I really like this picture just because of these custom copper bus bars. So sell them the system, get them in the door if that's what they can afford. If maybe they have small loads at the time, let them know that we can always expand to meet the growing family or maybe the growing budget. No maintenance is going to be a key feature for some installers I know out there. The last thing an installer wants to go do is go out and water batteries, take care of systems, spend, don't do truck rolls doing maintenance, do truck rolls to install new systems. Lithium ion batteries of any chemistry don't vent or release gas. They don't need work over time. Lithium iron phosphate specifically has a very low self-discharge rate, so it's going to hold that, that charge. It's not like your car battery where it's going to discharge relatively quickly, 1% per month. You're going to be able to come back to that battery, not maybe a year from now, and know that it's still going to work for you. This is an example of what it looks like to do a lead acid battery bank replacement. Here's a bunch of L16s, flooded batteries. What a mess of wires. We were able to come out. These are older SimpliPhi's here, but we were able to replace this battery bank with this set of batteries here. This picture on the right has just as much storage capacity and just as much power throughput as the picture on the left. So it's a great way to clean up an older system. As long as that older pieces of equipment, those older Outbacks, those older Schneiders, those older Morningstar equipment can meet the custom set points that we're looking for on lithium ion batteries, go ahead and use them. Most of them can. When we're approaching a customer, we want to stress safety. And again, that's what SimpliPhi Power was founded on. The last thing we want to do is put a large battery bank on the side of your home, on the side of your business, on the side of your castle, or worse yet, inside a garage, and have the risk of it going into thermal runaway. Cobalt-based batteries, they're more energy dense. They definitely have a time and place in mobile applications like our phones, like our cars, like our laptops. But when we're talking home storage, we're not really concerned about energy density. We're concerned about safety. So have that conversation with the homeowners, talk about thermal runaway, and understand that certain chemistries can internally have chemical reactions, essentially become these self-propagating fires. And we've gone through some testing. I'll go through this testing here in a second. But really what can happen is you get these micro short circuits within the cell. They start to self-propagate and spread to other cells inside a battery module and perhaps other battery modules next to that battery module, and maybe into your garage or into the home. These thermal runaways can also be caused by puncturing, like I mentioned with those pouch cells, and also overcharging. Really anything that can increase that temperature enough where those chemicals become a self-sustaining exothermic chemical reaction. The temperature at which, so even if you were to force one of these lithium iron phosphate cells into thermal runaway, the temperature at which the material burns is a lot lower. So LFP is around the 400 degrees centigrade. NMC cobalt is going to be up at 675. And the temperature at which you need to reach in order to initiate that reaction is a lot lower with lithium iron phosphate, 200 degrees before it begins, whereas it only needs 170 degrees centigrade for the cobalt-based chemistries to go into that self-propagation mode. The gas, without going too deep into it, the chemistry of it, there's a lot more potential for gases to escape out of a cobalt-based chemistry. You're going to get a lot of off-gassing, a lot of flammable toxic gas, whereas an LFP, and I'm going to probably use these acronyms, LFP, lithium iron phosphate, they don't have as much potential it because of the chemistry to release that gas. And using our form factor of that cylindrical form factor, it's going to contain that gas discharge as well. This chart here, so what do we have? Down here on the bottom is temperature, 0 to 450 degrees centigrade. On this axis, the y-axis, what do we have? We have the rate at which it heats up, centigrade over minutes. So these NCA, NMC, these are cobalt-based chemistries. So you can see as they hit a temperature, they're going into this thermal runaway, they get incredibly hot. I had to break out the graph just to show you and zoom in, just to show you exactly how low the lithium iron phosphate chemistry can meet. So I don't expect everybody to go into chemistry talks with the homeowners, with the installers, but it's important to understand how inherently much more safe certain chemistries are over others, and really drive that home when we're having those conversations about what's safe for your home, what's safe for your business. This is some of the cooling systems here that you're going to see in some of our competitors' batteries. I'm not going to name who these are, but there's liquid cooling systems in some of these other competitor batteries. These are added costs. These are other points of failure. These are other devices that need power to run pumps. So by not having these other items, we're removing other points of failure, that parasitic drain on the battery. And we're not needing those other ventilation equipments. So we want to make it simple or simplify. And so it's one less thing to break to keep it stable. A lot of people might say, well, what about lead acid? Lead acid's been around forever and it's pretty safe. I would agree. I would agree lead acid, it definitely is safer than some of the cobalt base, but it's not entirely unheard of for there's to have some events in lead acid systems, especially if you're letting the water drain in the battery and maybe you're not venting the gases properly. So we can have those conversations about lead acids. And I know, like I mentioned, our 3.85 battery is a great drop-in lead acid replacement. So you don't have to believe me this whole time that we have a safe battery, because we've gone to the UL. We have UL 1642 on the cell level, those cylindrical cells, 1973 on the battery module level, 9540 on the system level. And we've further gone to 9540A, which is a separate test protocol, where they essentially forced one of our battery cells into thermal runaway. It took a lot of heat to do this, and then watched what happened. Essentially, not much happened. And you can go onto our website and look at this if you want to really dive into it. The cell caught fire. It propagated to some of the surrounding cells, but no further. It didn't continue in the battery module. It didn't escape from the battery module to other modules. So it's a great win to show and prove just how safe these systems can be. You're always going to want to see these UL listings, even if you're off grid, to sell the system. If you're having this system inspected, your authorities having jurisdiction, your inspectors are probably going to be looking for this UL listing. Of course, you always want to check with them beforehand, just to make sure you know what they are going to be asking for. You don't want to wait to the end of the day just to find out that you bought some other piece of equipment, doesn't have the UL listing, and now you're failing inspection. One thing that definitely rings true to a lot of people when you start talking about lithium iron phosphates versus some of the cobalt-based chemistries is conflict minerals, and where do we obtain the materials to build the battery? So cobalt is a conflict mineral. It's mainly mined in the DRC, Dominican, I'm sorry, I'm spacing on the name, in Congo, in Africa, where some of these mines definitely are mechanized, but some of them aren't. And to understand that there is always cost to everything we use in this world. And how does that affect other people? By going with lithium iron phosphate, we're able to source that material in a much more sustainable way. Essentially, they push water underground. It forces up this slurry. They evaporate out the slurry, and we're able to harvest the lithium rather than having to mine these cobalt-based chemistries. I'm going to really quickly run through the products because I want to spend a little time at the very end to talk about some of the tools that we have on our website to help you make some of these sales. This is our standard Phi 3.8, one of our best sellers, either 24 volts, 48 volts. We can scale these up. They make that great drop-in lead acid replacement, and it has that simple battery management system that's internal to the battery only. Again, it also has that circuit breaker, an 80 amp circuit breaker on this model. We make a smaller version. This one's great for mobile applications, for smaller cabins, the Phi 1.4, and this version comes in 12 volts. So if you're looking for the old school 12 volt systems, this is what you're going to want to go with. You may have seen some of these older ones with the Anderson power pole connectors. We've since upgraded these to have the 3/8 inch terminals like you see there, just like our standard Phi batteries. Again, it has that battery management system in the breaker, so you're not going to short that out when you're installing it. Definitely have some energy storage systems. This is that access cabinet I was talking about earlier. Solarc on the top, some SimpliPhi or standard Phi or SimpliPhi batteries you can put down at the bottom. Really, this comes pre-programmed, pre-wired, so you can quickly AC couple it up to something that has existing solar. Maybe you got a home with some microinverters up top. Well, let's go ahead and just land it right there in the solar. If you got some new PV, let's go ahead and DC couple it. It has a NEMA 3R cabinet, so we can put this system outside, and we do have the 9540 on it. The SimpliPhi battery, we know it's the SimpliPhi battery because it has the comms ports up here at the top. This one has a slightly higher discharge, but essentially it's the same size and weight as our standard Phi battery. So we're able to use existing battery cabinets and wall brackets. It does have that closed loop communications, and you don't need that external card. One thing I should have mentioned in that history of SimpliPhi slide, and I've been using that slide for a while, is we were recently purchased by Briggs & Stratton. We've just come to market with a completely vertically integrated energy storage system. And this is my teaser slide. I'm going to talk a little bit about it here in a minute. We have our new inverters with a new 4.98 kilowatt hour battery. It's incredibly similar to our SimpliPhi battery, same chemistry, same form factor that we've always been using. And we also have an energy track app. So we'll talk about that here in a second after I go through some single line diagrams with you. This is what it looks like. When you show up to a home, somebody has existing solar, more than likely they're going to have some solar panels with some N-phase micros going into a little gen sub panel, feeding back to their main. We can come in, AC couple into this system. Now that's a Schneider XW Pro there, but we could use some other pieces of equipment, our new inverter, or even a solar. Go ahead and add in our batteries. This is our Boss 12 battery cabinet here, feeding into a Midnight solar combiner with another Boss 12. That's a big system. If you only had one Boss 12, you wouldn't necessarily need the combiner. You could feed that right in. Here's a DC coupled system. Excuse me. Here's a solar. We have a Tigo transmitter sending that keep alive signal up to these, looks like TS4Fs up here. We have our two Boss 12 cabinets feeding into a combiner right up to the solar. We can backfeed our loads. So again, really excited that we're now working with we're part of Briggs & Stratton, and we've come to market with this energy storage system. We have a 6K inverter, 4.9 kilowatt hour battery, and an energy track. A lot of homeowners are looking for these apps. So when it comes time to talking to a homeowner, don't forget to talk about the app. The app is gonna give them the control that they're looking for. You can talk about how you can change settings. We can put these into storm watch modes. We can understand how to dynamically change our reserve level for time of use. They can see what's happening so they can make adjustments on the fly. It's the third leg of the stool, as I like to talk about. So the inverter can be scaled up to 9 inverters up to 54 kilowatts. It has that 8 millisecond transfer time. So tell the homeowners, you're not even gonna see your lights flicker. You might not even know, you're not gonna know the power went out unless you have that app, unless you maybe go out and look out the window and see your neighbor's power's out. It does have a digital face, which I've always liked. A lot of competitors have gotten rid of all of their displays on their pieces of equipment, and I still like the old pieces of the pieces of equipment that still have the old school display. Really, you're not going to want to use that. You're going to want to use the app to do all your programming, to do all your commissioning. But if you got somebody who's a Luddite and they don't want to use the app, you could still go out to the screen and look at it. If you really wanted to, you could program it from the screen. IP65 rated, so you can put this outside. You're not going to have to buy one of those big cabinets anymore. 10-year warranty. The battery is also IP65 rated, so you can put this outside next to the pieces of equipment, next to that inverter. It's still using that integrated battery management system with our 10 years of experience building these batteries. We're really bringing a safe battery to the market that has a lot of capabilities. We can scale this up to 358 kilowatt hours. It has that same 10,000 cycles at 80% depth of discharge as our Phi and SimpliPhi batteries do. 10-year warranty. Again, I don't want to just skip over the app. I think it's really important to talk about apps when you're selling pieces of equipment. It can be the thing that the homeowner interacts with the most. And we've put a lot of work, a lot of effort into creating this app, pushing over-the-air firmware updates, making it easy for the installer to commission this thing. You're not having to sit out there in the rain for a day, for a half a day, waiting for things to commission. I've been there. We got better things to do than commissioning a system for half a day. It's a quick 5-step process where it gets that system up and running. All the firmware is stored on your phone, so it pushes it right to the pieces of equipment. So keep an eye out for this. Our new vertically integrated battery ESS system, it's 1 warranty. We've made it sure that it's all compatible. 1 tech support phone call, 1 installation manual, 1 app. I'm going to quickly run through some of those tools that I was talking about for the resources, and then we're going to wrap it up. It looks like we're going to wrap it up here, before around the 45-minute mark or less with questions. So we wanted to make a lot of resources for everybody, homeowners, installers. On our website, on the support tab, we have spec sheets, manuals, integration guides. I think that integration guides are probably the most powerful of all of the support there. These are documents that we've created for specific pieces of equipment, whether you have Schneider, whether you have Outback, whether you have Victron. There is a guide that will tell you how to program the systems in the order that the systems are asking for those programming settings. Check them out, print them out, have them in the van, the truck before you go out to site, so you're not having to rely on the internet. Of course, we have training videos. Of course, we have great people here at SimpliPhi Power, Briggs & Stratton. We have sales application engineers. We have a great tech support line where we're going to pick up. There's always usually somebody there. It's very rare that it ever goes on hold or to a voicemail. So initially, we're going to have to talk about sizing the system. The first one I want to talk about is the PHI 3.8 battery bank calculator. This is probably the most simple of the calculators. You just put in how much consumption do you have, how many days of autonomy. It's going to tell you how many batteries you're going to need. Of course, you're going to need another calculator to calculate those loads for you. This system-based calculator is a little more powerful. It does essentially the same thing, but it starts asking about, are you AC coupling? Are you DC coupling? What type of equipment do you have? What charge controllers, inverters? So this is going to help us make sure we don't exceed the maximum continuous charge and discharge rates of our batteries. Remember, I mentioned you have a C/2 rating on our batteries. So you never want to charge or discharge our batteries faster than 1.9 kilowatts. This knows what pieces of equipment are capable of, and not only takes into account the days of autonomy and the consumption data that we had already previously entered, but it also makes sure that pieces of equipment aren't going to exceed that charge rate. So maybe your autonomy only needs 2 batteries, but you got this big old Outback on it, charge controller or inverter. You're going to want to upsize that battery bank simply for the fact that you don't want to exceed the continuous charge or discharge cycles. Lead acid replacement calculator, it's kind of self-explanatory. If you come out to someone who has lead acid batteries, put in what they have. This is going to tell you what you need in SimpliPhi batteries. One thing I wanted to spend a little time on this one of all the calculators, because it's most applicable to what we're talking about today, is when we're sitting down at the kitchen table with a homeowner, we want to help them see past the upfront price of a system and have them understand the cost of the system over its life. Essentially, how many kilowatt hours can we put into this battery and take out of the battery over its warranted life? That's going to help them understand the value of the system. This is a great calculator. You go ahead and put that. You can enter in what you're essentially quoting out, and then compare that to competing lead acid batteries and competing lithium ion battery chemistries. It uses math. So it takes us out of that salesperson role and puts us into that energy consultant role. And by using math, we can really help educate the customer and not just sell the customer what's going to be the best value over its life. And so if anyone has questions on that or wants to run through that, let me know. I'm happy to help talk more in depth about that. Lastly, I want to go ahead and plug the Elite IQ Installer Program. If you're already installing our batteries, please reach out to us. We'd love for you to become part of our IQ program. Essentially, we put you on our maps. We have some cash back programs, a photo contest, a $250 monthly photo contest, $25 cash back per battery. Send you some shirts, some t-shirts, some swag, put you on our newsletter. It really helps design to drive you business for somebody in your area that comes to our website looking for someone. We'll send them to you. I love the photo contest. I love seeing photos of people. Pieces of equipment are always great. I love seeing great installs, but I love to see people in the photos. It tells a story. It gives us a feel for what people are doing with these systems and who they are. So if you want to enter in your photos, we can give you $250. And if you don't win 1 month, we're going to go ahead and roll that entry over. There's the link. Again, everybody's going to have a copy to this presentation. So we'll be able to get you on our maps. If you have difficulty with that, trouble going through the application process, reach out to me. My email is training@simpliphipower.com. Sorry about that. And with that, thank you. I have my colleague, Matt Walker, here with us. And if there's any questions, now is the time to put them into the Q&A chat. I did want to also plug our next week's training, which is a NABCEB accredited course. This one is not. Next week, we're going to be talking all about battery management systems. So if you're interested in that, please go ahead and join us next week, and we will talk to you then. So let's go ahead and check out the questions. I don't see any. So thank you. Matt, did you?
No, I think you answered everyone's questions already. Sounds like nobody was confused, so you did great.
I did it all. Thank you everyone for joining us. Look for upcoming to this new energy storage system. Really excited about it. Thank you, Matt, for being on the call with us, and thank you, everybody.